Good morning. Actually, I've got some news today. This actually will be our last video lesson for this course. I'm sure you're really glad to hear that. You're likely tired of hearing my voice. And to be honest, I'm a little tired of talking to lined paper. So let's go ahead. This is solving exponential equations, example 1. So we can solve this kind of equation by taking the logarithm of both sides. The reason we do this is because now we are able to utilize this last property of logarithms, which allows us to bring that exponent forward. So the x, which was an exponent, is now multiplied by log 3. Now, the logarithm of 3 is just a number. So to isolate x, we simply divide both sides of the equation by that number. So we will have the log of 1 over 81 divided by the log of 3 as our answer. Okay, and you can use your calculator to evaluate this. So the log of 1 over 81 divided by the log of 3. You can see the answer here is -4. This may be an answer you would have predicted. If you know that 81 is 3 to the power of 4, you could have guessed the value of this x equal to -4. Okay. They won't always be integers, however, so let's move on and look at this example. Since we have a base of e here, it makes sense not to use log, which is the common logarithm of base 10, but rather to use ln. We know that e to the x and ln x are inverses of each other, so that's why we make this decision. So we'll have the ln of the left side is equal to the ln of the right side. That allows us to bring the exponent forward, so it is -x multiplied by the ln of e. Now, what is the ln of e? Since the ln function has a base of e, we now have the base of e equal to the argument of e, which means it's a specific example of property 2. The ln of e, therefore, is equal to 1. So you might want to add that to your property sheet or even to your note here. It's a special case of property 2. The ln of e is equal to 1. So we now have this. -x times 1 is the ln of 17.54. So the value of x is the ln of 17.54 divided by -1. Or just the negative of the ln of 17.54, however you prefer to view that. And we'll just put this into our calculators and round to 3 significant digits. Okay, so the ln of 17.54 is this number. If we divide by -1, we get this number, roughly -2.86. It's important to note here that we could have used ln in example 1 as well, the whole way through. If you punch into your calculator the ln of 1 over 81 divided by the ln of 3, you will also get -4. Okay, let's try the third question. We're going to begin the same way. We can choose log or ln. there is no base of e or 10 to lead us one way over the other. So I'm going to do the log of both sides. That allows the whole exponent of x minus 1 to come forward as a multiplier, like this. So how are we going to isolate x? We kind of have two choices. We can open up the bracket, or we can just divide by log 5 at this point, which I think I will do. Okay, so we change from this multiplication by the number log 5 to division by the number log 5, like that. Now in isolating x, we just have to move this. So here's where we will change from subtraction of 1 to addition of 1. So this is correct for the value of x. We work it out. Log 2 divided by log 5. Add 1 and round to 3 significant digits. 1.43. Okay, so those are our first 3 examples. Again, you have a choice between using the common logarithm or the natural logarithm. When you see a base of e, for sure you should use ln, the natural logarithm. If you see a base of 10, which we have not seen here, then for sure you would use log. In all other cases, you have a choice. Okay. Let's look at this one, a 4th example. Now look, we have right here a power. Let's move the 5 first. When we move it, we would use division. So 7 divided by 5, which we could leave as a fraction. Or we could just change that to 1.4 rather, sorry. Like this, okay? So next, this question looks very, very much now like number 1, for example, where all we have to do is take the log of both sides. So the important thing is you have to move this first. Okay, and now you can proceed. So the log of the left is equal to the log of the right. Bring that exponent forward. So x times the log of 6 is the log of 1.4. And finally divide. So the log of 1.4 divided by the log of 6 will be our answer. And again, we can evaluate that. So log 1.4 divided by log 6. This is going to be 0.188. If we round to 3 significant digits, the 0, the leading 0, is non-significant. Okay, so that is correctly rounded to 3 significant digits. Okay, problem 5. Okay, now look, problem 5 is quite a bit different. I hope you'll notice that the unknown x is actually in 2 different places in the problem. So we have x to the power of 1 here, and we have x squared here. If you want the one of higher degree on the left, you can begin by changing this, but it's not entirely necessary. But I do rather prefer this. And now we do our logarithm of both sides. Again, choose log, choose ln, it will not matter. So log of the left, log of the right. You must use the same function on left and right. So what does this do? This means the x squared comes forward as a coefficient here. And the x comes forward here, like this. Now this is just a number, and this is just a number, a constant, you see. So in solving this now, we have to remember that we would first make the right side 0, because this is a quadratic currently. Okay, so we bring this term to the left side using subtraction. Now we have 0 on the right. We compare it to ax squared plus bx plus c equals 0. And we are missing the term c. We're missing that constant term. So if we were going to try to factor this, the only kind of factoring we could use is common factoring. The only common factor, however, would be x. So we can remove x as common from the two terms. What would that leave in this term if we divide it by x? It would leave x times the log of 2. Then we would have the subtraction sign. What would be left in this term if we divide it by x? Just the log of 0.6. Every time you do any kind of factoring, you could check it by opening the bracket up to make sure you get back the previous line. Now that it's factored, how do we get our x value answers? We take each factor and set it equal to 0. So x is 0 and x log 2 minus the log of 0.6 is 0. Nothing more to do here, so x equals 0 is one answer. But in solving for x here, we're going to first move this number to the other side. It will be positive. Then we'll divide by this number. And this gives us our second root. It's the log of 0.6 or over the log of 2. And we can find its approximate value. Okay, so log of 0.6 divided by log of 2 is, and we get this number here. So roughly negative 0.737. Okay, and by the way, if you did it all with lns, right? Ln of 0.6 divided by ln of 2 is going to be the exact same number. So we do have that choice from the beginning. Okay, quick recap here. We took the log of both sides. We recognized that x was present in both left and right sides, so we brought both terms to one side. This is quadratic. The exponent here of 2 ensures that this is quadratic, not linear. So we common factored the x, giving us one answer, x is 0 immediately. The other term is also set equal to 0, and x is carefully isolated. Okay, that one was a little bit involved for sure. We're going to do one more problem together. Okay, so this, yet again, has an x in the exponents of two different terms. but it's not quadratic because x is not squared here. Okay, so we don't have x squared. Okay, so we begin the same way, but when we see a base of e, remember it's our signal that ln will be easier to work with. So let's do it. We take the ln of the left side and we take the ln of the right side. Immediately bring those exponents forward. X plus 2 ln 5 is 2x ln e. Now, we spoke about this earlier, the fact that ln e is a special case for property number 2. The ln of e is 1. The other special case for property 2 is this. The log of 10 will also be 1. Because in this case, it is the common logarithm. The base of the common logarithm is implied to be 10. When the base matches the argument, the overall value is 1. When the base matches the argument. So these are two special cases for property 2. Okay, the point was that yes, this is a 1. So it's 2x multiplied by 1 here. So it's just 2x, okay? So I'm gonna write it here. We use the fact that the ln of e is 1. 2x times 1 is 2x. So now we have this. Okay, remember this is just a constant here. So the only way to solve this for x is to now open up this bracket. So we'll get x times ln 5 plus 2 times ln 5 is 2x. Now at this point, we have two terms containing x and one term without x. We must get those terms containing x on the same side of the equation. So I think I will bring this to this side here. Okay, that way this one can stay here where it is positive. But you could do the reverse. You could bring this to the left and this to the right if you like. But I think I will just move one term, and it's this one. Currently it's being added to this, to ln 5. So when I bring it to the other side, I need to subtract. Like that. Always the opposite operation. Now don't forget your objective. Your objective is to solve for x. That's why we brought the terms to the same side. Okay, how am I going to solve this for x? I'm going to remove the x as common like this. Okay, common factor the x. So that now it is going to be isolated completely once we move this number. This is just a constant, 2 ln 5, if you want to know what it's equal to, right? Sorry, 2 minus ln 5. It's this number, okay? So that's how many x's we have here. That's the coefficient of x. So to get x alone, we just divide by this coefficient. So we'll have 2 ln 5 divided by this number, 2 minus ln 5. Okay? And that's how we get our value for x. In punching it in, because it's a binomial in the denominator, if you're going to do this in one step, you'll have to put a bracket around there, okay? So 2 ln 5 divided by, now in a bracket, because it's two terms, a binomial, 2 minus ln 5. Close the bracket and then push equals. This is roughly 8.24. Okay, so x is approximately 8.24. 2, 4. Okay? So again, this one was a little bit tricky. After we took the logarithm of both sides and brought those exponents forward, we had this, an x here and an x trapped inside here. So we opened up the bracket, collected like terms, and then proceeded to isolate x. Okay, thanks a lot for watching those examples. These are the questions that I would like you to try. They're from exercises 13.6. You can try all of those from 3 to 13 odd. Also try 14. I have all of these solutions posted for you. So as you're doing your homework, you can check to see how you're doing. If you get stuck, you'll have solutions there to prompt you. Okay? All right, if you have any difficulties, don't forget that you can send me an email message as well, and I'd be happy to respond. All right, guys, have a great day. Miss you.